Let's take a look at the implementation of the PID controller in Python. So it's a very similar example to the ones that have been discussed before. So we take the current position of y is equal to 5 and we are going to compare that with the x values. So x goes from 1 to 30 and then we'll see how quickly does the system goes from the current value to the desired value. So desired value, the set point has been set to 0. And below that, we are just going to take the kp, kd and ki values. So kp has been set to 1.8, kd has been set to 0.15 and ki is set to 0.02. Now these variables or values are something that you can set on your own. You can play with them and see what sort of results do you get. Now in this case, as we will be taking into consideration the previous error and the cumulative error, both the variables had been set to 0. And there is a list that we have created. It's an empty list, y values, and we are going to append the changing y current values as we calculate the error and go on further. So let's take a look when the loop starts. So we are going to iterate through the values of x and we are going to calculate the error. So error is simple, it's y current minus y desired, as has been discussed before. And then when we try to change the value of y current, we use kp into error, which has been discussed before, ki into cumulative error, that has also been discussed before, and we look at how we are going to play with the d term, that's the derivative term. So what we do is we take a variable kd and multiply it with the change in error. So what has been the change in error for us? It's error minus the previous error. So for the first iteration, obviously the previous error is 0, but we will see how the previous error will change as the loop goes on. So this is the basic implementation of the D controller, how D will be implemented, and that is how the y current value is going to change. Once the new y current value has been computed, we are just going to append that value to the y values list, and over here we are going to say that previous error now becomes the error that was computed in this particular iteration, which will become the previous error for the next iteration. So that's how the previous error is calculated. And cumulative error is basically we are trying to sum all the errors which have been computed in the last iterations as well and this iteration as well. So we just sum up the error calculated in this iteration. So that's how the previous error and the cumulative errors will be computed. And then we just plot the values. So as it is pretty evident from the graph plotted that this time around the system reached the set point or the desired value pretty quicker in comparison to the earlier graphs or when only the P or the PI controllers were implemented. Now you can just see what values we got and how quickly with respect to the x-axis the system reached the set point. So it's totally up to you guys to do the comparison and take a look and play with the kp, ki, kd values. Obviously you are going to get better results than this that have been shown to you in the videos. All the best.